It's my pleasure and honor to introduce Dr. ARVIND Kumar MORYA. He is the chief instructor of this course and also a very good friend. He's one of the most dynamic academicians, researchers right now in Hyderabad, and he leads the ophthalmology department at AIMS BB Nagar. Today he will be talking about development of smartphone app for accurate image labeling for artificial intelligence in retinal disease. Over to you, sir.
Thank you, Dr. Charuta, for such a nice introduction. Yes, please start my PPT. Yeah. So good morning, everyone. So I will be speaking on our innovation, that is a development of a smartphone application for the accurate image labeling for artificial intelligence in the common retinal disorders. As we all know that the artificial intelligence is the fourth industrial revolution in the history of mankind, and technology has advanced dramatically in the recent decades. The iPhone Apple is 1 million times more powerful than all computers in NASA headquarters way back in 1985. So we can expect it to continue to advance at an accelerated rate in the years to come. What is AI? It is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. Then what is machine learning? It's an application of AI that enables systems to learn and improve from experience without being explicitly programmed. And ML focuses on developing computer programs that can access data and use it to learn for themselves. So this is how it works. First is the digitization through EMR. We all know this application, identification of the clinical parameters, then development of the machine learning algorithm is there. It is integrated with the ML model into EMR, then it quantifies the uses and it leads to clinical validation. So deep learning and AI have become widespread because of the availability of digital data, and supervised learning algorithms have shown human level performance. To get huge data set with good quality control, there is a need of an annotation tool with a customizable feature set. And this multicentric study evaluated the viability of having an in-house annotation tool which work on a smartphone and can be used in a healthcare setting. Supervised learning algorithms like the convolutional neural network have human level or better performance in radiology, ophthalmology, and in driving the automated vehicles, but requires huge amount of labeled or annotated data and high variance if the grader is an expert or a fresher. So there are various annotation tools available like the label box, supervisedly and labeling desktop-based graphic user interface, but it has many disadvantages of not being mobile. Progress of graders can't be supervised, loss of data because of hardware issue, no data exchange for the offline mode, and loss of annotations because of poor network. So for the commonly retinal disorders like the diabetic retinopathy, ARMD, glaucoma, we require better screening for early prevention and risk evaluation because millions of people are affected by these disorders, especially in the remotest of the areas. So the objective of this tool were to quantify the amount of damage already done, segmentation of the lesions, and at present IDX-DR by M. Abramov is the only US FDA approved AI-based equipment, but it is very bulky and very costly also. So we followed the ICDR, severity disease scale, for grading the diabetic retinopathy, and binary module based on CNN. So we developed a deep learning algorithm for referring the retinal disease or whether the particular image of that retinal disease is non-referable. So it begins with 32 retinal specialists and 8 IIT engineers with an online tool label box for labeling of publicly available data set, and then we started using our own data. So there were many advantages. We were able to grade multiple retinal images easily in a short span of time. It was user-friendly tool using user interface and user feedback. It was integrated with advanced testing and internal validation sets. It was faster and mobile. We were able to track progress, and domain expert feedback for graphic user interface was also available. It has many special features of zoom capacity of 3 options and green channel to obtain the red-free image of 24-bit. And we also had the brightness and contrast slider to make images gradable, because if the image quality is not good, we cannot grade it. So we had this brightness and contrast slider. And a smart image preloading system in a WebP format. It maintains resolution of images but keeping low memory footprints. So it's a small video. So this led us to develop our own in-house image annotation tool. As seen in the video, adding in annotations for an image is pretty easy. View the image, magnify it, change the brightness, change the contrast as needed. Click on the relevant option, choose the extra details, and the annotation is saved. The analytics on the landing page shows the pending and completed images. The graph shows the maximum number of images stacked by the other users in real time and gave the daily target settings. And these imaging data sets are generally in the range of thousands and can be overwhelming for a single surgeon. So we chunk them into sets, each containing 1,000 images or less, which a grader can complete within a week. The issues mentioned earlier were resolved as follows. For faster image loading, we resized images into smaller size thumbnails with a smaller memory footprint and is still maintaining the visual quality. We leveraged the asynchronous capability of the browser and didn't load just 1 but 3 images preemptively so that the grader doesn't need to wait for the next image to load. And the initial interface was basic and evolved based on the grader feedback. It is now designed on a decision tree structure to render the nested subclassification and extra options. So we have seen a total behavioral change where on the online tool the grader used to work. Right. I need to forward it. That's yeah. So we have seen a total behavioral change where on the online tools, the grader used to work only on the weekend, but on our tool, we have a logged uses on all days of the week. And the average time taken to label a single image reduced substantially. And we validated the AI algorithm developed using annotation on this tool on new testing data sets and found them to have a really high performance scores. So this strengthens our hypothesis that this tool is no different than the desktop-based tools and with added benefits of being portable and flexible. So we wish to introduce more gamification, label optimization to be used in telemedicine. So this is how it helps. So first there is a non-proliferative type of diabetic retina. So it goes into the algorithm and it tells the action plan. So there is no referral is needed. Whereas in the next picture, it is a case of proliferative type of diabetic retinopathy. So the algorithm is saying that intervention is required. So it require a referral to a retinal surgeon. So conclusion, the user feedback and feature usage stats after evaluating over 2 lakhs of retinal images confirm our hypothesis with high sensitivity. And now we are able to develop an offline smartphone app which can diagnose patients of common retinal disease in less than 1 minute, 53 seconds to exact, and very soon it will be available on Google Play Store. It is under patent, and this app will have a definite role in telemedicine and bridging gap between man and machine. And this app will surely transform patient management in the near future. And this article is published, our study in the clinical ophthalmology. You can read it in detail. Thank you so very much. Yes, if the image is feed, it is basically for the optometrist. Yeah, they need to have some knowledge because we need to capture the retinal image, right? Yeah, they can be taught. They can be taught.
Pocket, foldable, funda.
Yes, they can be taught. It's yeah. They can be taught easily. It's not a difficult thing. Yeah, it's no rocket science. It's very simpler and easy.
So wonderful innovation, sir. Very congratulations.